Okay, so question number 2. Using the VSEPR model, the molecular geometry of the central atom in phosphorus trichloride is linear, trigonal planar, tetrahedral, bent, or trigonal pyramidal. Okay, so to answer this question, we first need to draw out the Lewis structure for phosphorus trichloride. So we need to calculate the total number of valence electrons that are in this molecule. So phosphorus has 5 valence electrons and chlorine has 7. And since there are 3 chlorine atoms, we multiply this by 3. And when we add these values up, we get a total of 26 valence electrons. So now let's try to draw out the skeletal structure of PCl3. So phosphorus will be our central atom since it is the least electronegative, and we can form 3 single bonds to chlorine. And from here, I'll also draw in all of the lone pairs that can be found on chlorine as well. So if we recall that each bond contains 2 bonding electrons, and we have 3 bonds, and we can see that each chlorine atom contains 6 non-bonding electrons. So far, I have drawn 24 out of the 26 electrons in this structure. So for the remaining 2, I'm just going to place them on my phosphorus atom. So now I have the Lewis structure for phosphorus trichloride, and I need to find out its molecular geometry. So if we analyze the central atom, we'll see that the phosphorus contains 1 lone pair, and it has 3 bonded atoms. So if I use a VSEPR table, I can find out its molecular shape. Okay, so when a molecule has 1 lone pair and 3 bonded atoms, it has a trigonal pyramid molecular shape. And also, its electron geometry would be considered tetrahedral. Okay, so if we look at our phosphorus atom, it is sp3 hybridized, and the bond angles between all of the charge clouds would be 109.5 degrees. Okay, so let's see what the junior tutor said. If we look at all our different options, then I guess we would see that option E is our correct answer. And the junior tutor said, in order to know the molecular geometry of a compound, the Lewis structure must be drawn first. Applying the VSEPR model, the most stable structure of a compound is the form wherein the least repulsion can be observed. So there's a central P atom, and the chlorine atoms are connected to it. There are 5 valence electrons, wherein 3 of them can be used to share electrons with the chlorine atoms that would need only 1 more electron to abide by the octet rule. And then they drew out the structure. And since the central phosphorus has a lone pair, all of the chlorine atoms are pushed to the opposite side. This resulted in the structure in the figure above and forms a trigonal pyramid as its molecular geometry. Thus the letter is E. Yep. So the solution is correct.